Now compute 2 times A inverse. So one way is multiply A by 2 and find inverse. Another way is separate into is A inverse times inverse 2 is 1/2. So 1/2 A inverse. In my opinion, this is the easy part. I know that A inverse, remember, is 2/5, -7 and 6. Then 1/2 A inverse is multiplication by the scalar is 1, 5/2, -7/2 and 3. And this is the answer in this way, easy. Another way is, well, we have A is 1/47, and the matrix is 6, -5, 7 and 2. Then 2A is multiplied by 2. Entonces is, is 1/47 multiplied by 2 is 12, is -10, is 14 and 4. Now let's find the inverse. Inverse is 2A inverse. Is inverse of the number is 47. Times the inverse matrix of this. The inverse matrix is 4, 12, 10 and -14. Divided by the determinant of 2A. And the determinant of 2A is equal 12, -10, 14 and 4. Multiplication this is 48. Multiplication this is 140. And the answer is 188. This is 188. Okay, this is 188. And 188, when you simplify here, is divided by this is 1, divided by this is 4. So the answer is, let me erase this part, is divided by 4 everything. The answer is 4 divided by 4, 1. 10 divided by 4, 5/2. 14 divided by 4 is -7/2. And 12 divided by 4 is 3. Gives the same answer. Okay, this question is computed the determinant by hand using the property. And this determinant is the dimension A by A. Wow, too big. But we're using the property. The property helps to simplify the thing. For example, I saw every row contains only one number and the rest is 0. Now, for example, the row 1 have 1 here and the rest is 0. Would be fantastic this number when you interchange or swap the row is located in the main diagonal. When it is located in the main diagonal, you have diagonal matrix. And remember, the determinant of the diagonal matrix according to the property number 5 is the multiplication of the number in the main diagonal if the rest is 0. So for example, manipulate here, you see I have row 2 interchange or swap with the row 8. ¿Cuál es the idea? The idea is que these two go here, and of course we have 0. 0 here and 3 here, because these 3 go to the row number 8. Likewise, in order to put 3 here, you interchange row 3 and row 8. Because I have 3 here. This is 0 and this 5 go here. Okay. Now, okay, let me go. This is row 1, row 2, row 3, row 4, 5, 6, 7, and 8. Okay, and now I propose row 5 and row 4 interchange. Row 5 and row 4. Okay. Now what is the idea? The idea is, in this case, this 4 go here. We have 0 and this 6 go here. And we have 0 here. Okay, this is the moment to define. Entonces es row 8 and row 5. Entonces this moment, this 5 go here. This 0 now is here. And this 6 go here. And we have 0. Now I want 6 here. Let's interchange row 8 and row 6. Super. When you interchange row 8 and row 6, look at what happened. Interesting. These 6 go here. This is 0 now. And this 8 go here. It's exactly your place. And this is 0 here. Ready. So now the rest is just the multiplication. Multiplication. 1 times 2 times 3 times 4 times 5 times 6 times 7 and times 8. Now I don't know see this answer is positive or is negative. This depending of the row operation I change. I change 1, 2, 3, 4 and 5. Entonces es negative because it's when this odd number is 5 es negative. Entonces es negative. The answer is negative. Okay, I have put negative here. I multiply this. The answer is negative 40,320. Well, let's check with the calculator. Okay, I did the multiplication using the calculator. The answer is 4,320. Alright, now, by curiosity, I put a matrix A by A in my calculator. This matrix. I put in the matrix A. Look at the matrix. Yeah, I computed the determinant. And the answer was the same. The answer was negative 40,320. Good. Okay. Another way to compute that is using the cofactor formula. So you expand using the cofactor formula. Let's try to do. For example, we start for this number. This number is 1. Copy here. This is equal 1. I don't know if this one is positive or is negative. Let me analyze. This is a position cofactor 1, 1. It's row 1, column 1. And 1 plus 1 is 2. It's even number, it's positive. Now you delete this row and this column. And we obtain a new determinant, que is 7 by 7. And you expand using any row or any column, whatever. I select for this new determinant this element. Yes, 2. I don't know if this 2 is positive or is negative. The position is cofactor row 8, column 2. 8 plus 2 is 10. It's even, it's positive. And of course you delete this row and this column. And we obtain new determinant, que es 6 by 6. Okay, entonces I solve this new determinant. This new determinant I use in this element, que es 3. I don't know if this is 3 is positive or negative. According to the position, is cofactor 2, 3. Because it's row 2, column 3. 2 plus 3, 2 plus 3 is 5. 5 is odd number, is negative. This cofactor is negative. And you delete this and that. And the rest is 0, 0, 0, 0, 0, 0. Okay, now the new element is 4. The position of 4 is, remember guys, this is row 1, row 2, row 3, row 4, row 5, row 6, row 7, and row 8. This is column 1, column 2, column 3, column 4, column 5, column 6, column 7, and column 8. This element is located in the 5, 4. 5, 4. 5 plus 4 is 9, que es odd number, entonces es negative 4. And you delete this column and this row. We continue navigate for the determinant. Now the next guy is 5. The position 5 is 3, 5. E3 plus 5 is 8, que es even number, is positive. And you delete this row and this column. Okay, the last is 6. And the position of the 6 is 4, 6. And 4 plus 6 is 10. It's even, so it's 6. Okay, let's delete this and delete that. Okay, finally we have this determinant. Wow, 2 by 2. It's pretty easy. This multiplication is positive and this multiplication is negative. And the answer, this is 7 times a negative is negative 56. Okay, this is 7, negative 7 times a. And when you multiply, you get the same answer. We have 1, 2, 3 negatives. Negative 40,320. It's the same answer.